Okay, we're going to talk about radians, arc length, and sector area. Okay, so in order to get started, we need to talk about what is a radian in the first place. So a radian, by definition, is whenever you have the radius of a circle the same length as the arc of a sector of a circle. Okay, a sector of a circle is like a piece of pie. It's like a wedge of the circle. So whenever this length here is the same length as the radius, it then you've got 1 radian. So the measurement of this angle here is 1 radian. Okay, and if you look at this computer, you can't see it. Okay, if you look at this diagram here, it doesn't matter how big your circle is. You're still going to have, when it gets this far, you're at 1 radian. That far, you're at 2, 3, 4. It doesn't matter how big your circle is to get 1 radian. Now, there's 2 radians. 3 radians is about there, 6 radians is about there, and in order to get to here, so here we know, so here's 1 radian from here to here. Here's another radian from here to here. If you go all the way to about here, you're about 3 radians. There's 2 radians. So to get to here is 3.14 radians, which is about pi. So anyways, so we said here this is 2 radians, and halfway of the circle is pi. So what is the angle shown in degrees? It's 180. So the length from here to here, the length of the arc is going to be pi. And that happens when the radius is 1. When the radius is 1, this length here is going to be pi, or 3.14, if we're estimating. Okay, so by definition, if from here to here is pi, and from here to here is 180, we can say 180 degrees equals pi. And we're going to be using this important relationship in order to do conversions from degrees to pi to radian measurement, or from radian measurement to degree measurement. Okay, so if I've got, like I just said, we know that 180 degrees equals pi, right? So find the exact radian measurements of 90 degrees. So 90 degrees, if I multiply pi over 180, we know that the 0 is going to cancel out, and 9 goes into 18 twice, so we know that we've got pi over 2. And that should make sense, right? Because if you go back to our previous picture, 180 degrees is from here to here, so half, and from here to here is pi, so half of pi is going to take you to here. That's not really there. Which is going to be pi over 2. Okay, 45 degrees. Same thing. Multiply it by pi over 180. Oops. And then you're going to get pi over 4 when you simplify this and this. Okay. 120. Then the zeros cancel out, and 6 goes into 12 2 times, and 6 goes into 18 3 times. So you end up with 2 pi over 3. And you do the same type of thing to convert to from radians to degrees. Okay. So we just said this was r, right? Okay. So in degrees, the arc length of a sector by this angle is given by this formula. So remember, this right here gives us the fraction of the circle. So we're talking about arc length. Length is the circumference, right? We're talking about circumference. Right? So the length around the circle, so this is the fraction of the circle we're going to have, and this is the formula for circumference. Okay? So explain how this formula is derived. Okay? So that's what I just did. So it's the fraction of the circumference. Okay, so give the formula for the arc length when it's in radians degrees. So when it's in radians degrees, we're going to say it's the arc length is going to be, well, we know from here to here is the length, and this is my thing here. So we're going to say theta times the radius. Okay. So and this is in radians. Okay. Let me switch papers here. Okay. So C, since the angle measure, so explain why this matches the definition of 1 radian. So since the angle measure of 1 radian has an arc length of 1 radius, then the arc length of any circle is going to be the radius times theta. Okay, so the area for a circle is pi r squared, right? So give a formula for the area of a sector with radius r extending in radians. So we know, so if theta over 360 is the fraction in degrees, then over here we're going to use theta over 2 pi, because that's going to give us the fraction in radians. So to find the area of a circle, we've got our fraction in radians times pi r squared. And then this pi and that pi cancels out, and then we have theta over 2 times r squared, and that gets us our area of a sector formula when we've got theta is in radians. Okay. So when might you want to use one or the other? It depends on if you're, you probably would want to use radians for this area, because I think it's going to be easier. The formula for area of a sector when you're in radians is like this. These formulas seem pretty simple. And when you're trying to find the area of a sector in degrees, you can still do it, but there's a few more additional variables involved. Okay, next page. So this is a good so here we have our formulas that we just talked about, which are in your formula packet. And this is a good drawing of the unit circle Here we go from here to here is pi. Half of pi is pi over 2. Half from here to here is pi over 4. If we go further, we're adding a quarter pi. We're at 5 pi over 4. Here we're going to be at 6 pi over 4, 7 pi over 4, 8 pi over 4. Okay. So let's look at the first example here. Okay, in the diagram shown below, we've got radius of 5, and we've got the angle here is 1.1 radians. Find the length of L. So the length of L, it should be equal to, using this formula, it's going to be the radius times the angle in radians. So the radius times the angle in radians is going to give us 5.5. Okay, the rectangle above represents the garden length 6 meters. Security light is placed at point 8. Find the length of B to F. So from here to here, this length here to there, same as that there, right? So if I'm trying to find that, and I know the hypotenuse is this, I've got adjacent and hypotenuse. I'm going to use cosine to figure this out. So I can do cosine of that angle equals adjacent over hypotenuse, so x over 5. And so to find x, I can multiply 5 on both sides. Now be careful when you're using your calculator now, because now we've got to be in radian mode. So make sure you hit mode and change it to radian mode. Enter. Okay, and then second mode to quit. And now we can type it in, 5 cosine 1.1, and then I'm going to get that length from there to there is 2.27. Okay. Okay, now find the area of the garden which is covered by the security light. So the area of the garden which is covered by the security light is this area here and this whole area here. So I need to find the area of this triangle. So I could use, to figure out this height here, let's zoom out a little bit, I could use sine of 1.1. Now in class somebody said you should use, you can use Pythagorean theorem. Of course you can. If I know the hypotenuse and this leg, we can figure out this using Pythagorean theorem. But I just use sine because we've got the opposite and the hypotenuse. We could use sine. Okay. Anyways, area of a triangle is 1/2 base times height. Or I can use this formula. Did I use that formula? I don't think I did. Oh yeah, yeah. So this is side 2.27. This right here is side 5, and we did sine of 1.1. Okay. Then the area of the sector is this part right here. So we know that it's 1/2 r squared theta. So we can do 1/2 5 squared, and theta we know is 1.1, and then we get 13.75. Okay, so the garden, you're going to add them together to get this. Okay, so as I mentioned on the first earlier page, that we're going to use this relationship, 180 equals pi. So, so on the first problems here, let's zoom in some. So everything is in degrees. So if I multiply everything by pi over 180 and simplify, then we're going to be able to get everything into degree mode. You might want to hit pause and check your answers. Now in question 2, I'm going to multiply everything times 180 over pi. And by doing that, it's going to cancel out the pi, and then we're going to end up with our answer in degree mode. Okay. So you might want to hit pause. Okay, question 3. Find the length of the arc. So once again, the length is the radius times theta. So we know the angle here is 2 pi over 3. The radius here they've told you is 7, so we can figure out the length of the arc is 14.1. Okay. The area of the sector, of the whole sector, from there to there, is going to be, using the formula, what did we say it was? Equals 1/2 r squared theta, right? So here I have 1/2 7 squared 2 pi over 3. Multiply those all together and I get 51.3. And then C, use an approximate formula to find the area of the triangle. So here we have the area of the triangle here, and so from our formula sheet from before, we've got the area of the triangle equals 1/2 AB sine C. So you might recall that if we're at point C, this would be lowercase a, lowercase b, right? And this is angle C. Okay, so so the area of the triangle is going to be 1/2 7 times 7 sine of 2 pi over 3. Make sure you're in radian mode, and then you end up with 21.2. Okay, now hence find the area of the segment that's cut off by chord AB. So we want to find the area that's shaded here. So to find the area shaded, you're going to do the area of the whole sector, the pi, minus the area of the triangle. Might want to hit pause if you need to think about that some more. Okay, next. So I wish I had put more space here to solve this, but that's how it goes sometimes. So where's my paper? Here we go. Okay, so to find the perimeter, we know that the length is our theta, so that's going to be 3 times 0.7, which is equal to 2.1 centimeters. Okay, now we know this, if I want to find the perimeter, that's going to be equal to this length plus this plus this. So we know that's 3, we know this is 2.1, and we know that's 3. So the perimeter is going to be 3 plus 3 plus 2.1, and so my perimeter is going to be equal to 8.1 centimeters. Okay. Now the area of the sector is 1/2 r squared theta, so we're going to get 1/2 3 squared 0.7, and then we plug that into the calculator, and we get the area equals 3.15 centimeters squared. Okay. Now for question B, we're going to do just like we did on the previous one. In fact, this is the same question as the previous one. If you look back at the previous one, notice it's 7, 7, 2 pi over 3. So we already have the answers. We just did this. So, the perimeter, so we just did this. We know the arc length is 14.7. So that's this part right here is 14.7. And then this length here, we need to know that length, don't we? We don't know what that is, do we? So, so to figure out that length, I need to do something with this triangle. Now, if I'm looking at this triangle, and I know this is 7, 7, and 2 pi over 3, I can use the law of cosine to figure this out. So if I'm using the law of cosine, then I can see that x squared equals 7 squared plus 7 squared minus 2 times 7 times 7 cosine 2 pi over 3. Okay, and then I end up with x squared equals 147. And then I take the square root of that, and I get x equals 12.1 meters. So now I know this length right here is 12.1. So now to find the perimeter, I just add those two together. And so my perimeter equals 26.8 meters. Okay. Okay. Now we need to find the area of this thing. So, and we already did that on the previous assignment. We did the area shaded minus the area of this area of the sector minus the area shaded, and we got 30.1 meters squared. Okay, and that was in problem number 3. Okay, so now let's look at question C. Okay, same kind of thing. So let's find the let's do the area of the area of the sector is equal to 1/2. What's our formula again? There's 1/2 the radius squared times the angle. So 1/2 6 squared times that. So we know the area of the sector is 36 centimeters squared. The area of the triangle is 1/2 6 times 6 times sine of the angle. And if I put it in the calculator, I get this. And then the area shaded is equal to those subtracted from each other. And so the area shaded equals 15.6 centimeters squared. Okay. Now let's find the perimeter. So we know the arc length. That's easy to find. That's equal to the radius times the degree in radians. So we know that that's going to be 6 times 2. So the arc length is going to be equal to 12 centimeters. Right? But I need to find this length here. So I'm going to need to use the law of cosine. So I know this is 7. That's 6, 6, and let's call that x. So if I'm using the law of cosine, I've got x squared equals 6 squared plus 6 squared minus 2 times 6 times 6 cosine 2. And then I'm going to, if I simplify all that, I get x squared equals 101.96. And if I take the square root of that, then I get x equals 10.1 centimeters. So that's this length here. And so my perimeter is those added together, 12 centimeters plus 10.1 centimeters. So my perimeter is equal to 22.1 centimeters. Okay. And last little bit. This is very similar to the earlier problem we did, example 1. So I'll just put this here for you to check your work. And problem number 6 I will do in a separate video.